This is another example. This question is rational function. Is this with rational? Rational means fractional. It's fractional in nature. So this particular one, we can call it, we can use quotient rule here because it is division, purely division. Yeah. So normally, you know what quotient rule says, that you have to use the quotient rule formula, which says if we are calling this u and calling this v now, the quotient rule says that we are going to use v dy ds equals to v du ds minus u dv ds. That's v du ds minus u dv ds all over v square. All over v square. So this is the v square you're seeing. So v is the denominator. This is a v now. So we're taking it here. So we now do du. This is u. So we do du ds. If you differentiate z with respect to, sorry, if you differentiate this in with respect to z now, because this is z and no longer s. If you differentiate this now, you are going to have 1. Multiply it by the v under here. Then differentiate v. You have 2z. Multiply it by the z, which is u. You have this now. So when you expand, z times 2z is 2z squared. Then you expand this 1 times z squared, 1 times 1, you have this. So when this and this go together, you have minus z squared. So that's just what was done here. Now, assuming you were told to write it in terms of s and y, look at this, how it is going to be done. Although it is complex, right? But just in case you were asked to do it, you just have to replace the z and the z here by s plus iy as usual. When you do that, if you put s plus iy in their term, that's these two now, you are going to have this. So you expand them, that stuff separately. Expand the numerator. Before expanding the numerator, first of all, expand this. This expansion will give you this. Remember what I normally say, get this thing into 2 and place them side by side and expand. Then when you have gotten that, the next thing is to write this in the way it is complete. So instead of writing s plus iy squared, you're now going to have what you got by expanding it, this one now, inside there. Then 1 minus this now. So when 1 minus this, the minus will change out the sign inside there. The plus sign in front of s squared will become minus. Minus sign becomes plus. Plus sign becomes minus. You see that? This is our numerator. We now go to our denominator. So this is our denominator. We are going to first of all do the addition. That's adding this to 1. You see that? After we have expanded this, so we did it before, so we now add it to 1. So you see that it will give us this. When you do it very well, to give us this. Now, after we have done this, the next thing is we go further to replace it. To replace this by the denominator, replace this by the numerator. That's the result we got from numerator and denominator. So when you do that, you're going to have this under here. So you can still go further to get your real and imaginary part, but let's just stop here. So if you want to do that, actually, you have to expand this again. Or you can still just make this one to a minus, multiply both up and down by what you have. Just maintain the square as well. You maintain the square. So the conjugate will come with both the square and the minus sign, multiply both up and down. Thank you.